Hi, I'm going to show you how to add vectors. So I have a vector A with a length of 8 and a direction 20 degrees clockwise from the positive y-axis, and I have vector B with a length of 6 and a direction of 50 degrees clockwise from the negative x-axis. Okay, so first thing I do when I'm doing vector addition is I make sure that all of my angles are measured counterclockwise from the positive x-axis. So for example, A is 20 degrees clockwise from y. I want this angle right here, which is counterclockwise from positive x. And I'll just go ahead and rewrite the vector using more conventional notation. So magnitude of 8 and then a direction of this angle right here, which is 70 degrees. And then likewise B, I need to convert its direction to be counterclockwise from positive x. So it's 50 degrees from negative x. So this angle here would be 130 degrees. So just taking 180 minus 50. Okay, so my goal is to add A to B. I'm just going to go ahead and give that a name. I'll call it C. So C equals the sum of A and B. What is that? So I am going to have to convert them to x and y components first. I can't just take 8 plus 6, call it 14. That's wrong. So it's a little bit more complicated from that. So I need to, like I said, convert these things to x and y components. A little bit tedious, but just have to grind it out. So I want to find x component of A. I'll use A times cosine theta. So when I measure counterclockwise from positive x, I know that the cosine function is always associated with x. And I don't even have to worry about the sine. The sine of this calculation will work out, and I'll be in the right quadrant. So A has a length of 6, a direction of 70 degrees, and I throw that in my calculator, and it spits out 2.74. And then the sine function is associated with y when I measure counterclockwise from positive x. So I just obey the formula, and it tells me that it is 7.52. Okay, and then I can do a very similar thing with B, just cosine associated with x, sine associated with y. I'm not drawing any triangles here. It's really not necessary when you're doing vector arithmetic. Okay, throw that into my calculator and I get minus 3.86. And one thing you can check is, if you're not 100% confident in your math, is to make sure that you're in the correct quadrant. And this looks right to me. I have a negative x component for B. A has positive x and y components, so looks good so far. And then once again, sine function associated with the y component. And my calculator says that that is 4.60. Okay, so now I'm going to now I'm ready to add the x components and add the y components together to get the x and y components of the sum. So I just take 2.74, the x component of A, and I add that to the x component of B, and I get minus 1.12. And then similarly, I can add the y component of A to the y component of B, and I get 12.12. Okay, so I'm basically done. I have calculated the vector sum of A and B in terms of x and y components. Sometimes we want to get another way to report it, which is back to a magnitude and direction, which is how our original vectors were reported. So I'm going to go ahead and do that. So C, meaning the magnitude of C, is just the square root of the sum of the squares of the x and y components. And so I just throw in negative 1.12. And you got to be careful. You do want to square the minus sign, so don't put the minus sign outside the square. And then 12.12 squared. And then I throw that into my calculator, and it spits out an answer of 12.2. Okay, so there's my magnitude. And then we just need to calculate the direction. So the direction comes from inverse trig. So we have to do an inverse trig function, inverse tangent of y over x. And I throw in 12.12 over negative 1.12. And my calculator says minus 85 degrees. Okay? That's clearly wrong because my x component is negative, my y component is positive, so I should be in this quadrant, somewhere over here. And so negative 85 would be down here. So what happens is when you use inverse trig functions is that sometimes they give you wrong answers. You're basically telling your calculator, give me an angle whose tangent is this. And it just picks one arbitrarily, and it always picks in this region here with positive x components. So when you have a negative x component, just take what your calculator tells you and add 180 degrees. So I take minus 85, add 180 degrees, and I get 95 degrees. Okay, so plus 180 is the correct answer. Okay, so there it is. I've got the magnitude and direction of the sum. I also have x and y components of the sum, and so I've added up these two vectors. Okay, thanks for watching.